Today we'll discuss handling exceptions within our applications. An exception is basically something unexpected which happens while your application is running. But this isn't the most accurate definition for exception. An exception is a special kind of event which is raised by a method in the class because it either does or doesn't meet some kind of condition that was expected. It's up to every method of every class, this could be classes in the .NET framework or classes created by you, to make the decision of either raising the exception or not, and why and when. Normally it's because there's something about the state of the application or the values which are input into the method that are somehow invalid. If and when this happens, the method cannot continue to execute. So it has to raise an exception, hoping the code that called that method can easily handle what's happened. So for example, say we have a method like the button1click event and the event handler calls a method of some class in the .NET framework. Say that this is the constructor of the system.xml.streamReader class and we pass in an invalid file location to the constructor. But this is a problem because the StreamReader class can continue, so it throws an exception. The StreamReader has to tell your code that something was wrong and it couldn't continue to run. So it gathers all the information into a special object called an exception object. The exception object is passed to the code that called the method originally, hoping it'll know what to do. Now the code you've written that calls the ScreenReader's constructor method could ignore the exception or it can handle the exception. So far, the exceptions have all been ignored, so our code isn't very strong and can break quite easily. But there is some special code that can be written which checks in case something bad happens as we're calling the StreamReader method. If it does, then it ensures the code can handle it. This is done by using a try-catch statement within our code. So when we write code, we need to be able to spot those lines of code which could easily be broken and then add these try-catch statements around them. Now the exception class is the base class for all exceptions. So in the last lesson we saw whenever the .NET framework tried to open an XML file but couldn't find it in the directory it assumed it would be in, then the file not found exception was thrown. The file not found exception derives from the system.exception base class. The reason we need to use specialized versions of the exception class is so that your code can find out what the exact problem is and respond accordingly. i.e. if the exception is of type file not found exception, so the simple solution is to tell the user and then allow them to find the file on their hard drive using some type of dialog. Maybe the file could be corrupt, then there's a different exception for that which needs a different error message to the end user, and maybe a slightly different way to fix the problem. Or maybe the file doesn't contain any XML or there could be other problems. So with the specialized versions of the exception base class, you can choose the right way to handle your application if possible. If it's not possible, you can tell the user what the problem is and ask them to do something else like please pick another file. In the framework there's many different exceptions which have been defined that are all deriving from your system.exception base class. Now we'll discuss that you should anticipate the problems that can occur within your applications. Once you've anticipated those, then you need to write try-catch code around those possible problems. Ideally it would be great to resolve the problem without involving the user. However, if the user is needed to resolve the problem where they may have to choose another file, then that's also fine. However, you should never let the application break and leave the user confused about the next course of action. So what we'll do is create an application which can intentionally be easily broken. We'll then see the results where we don't handle the exceptions and then wrap some try-catch statements around the code and see how to handle the situation a little more elegantly. So we'll create a new project called Lesson 11, a simple Windows Forms application, and we'll put a box and two text boxes. This will be a basic calculator where we can add two values together and more. So I'll double click my button and paste some code. I've created a value called result, and I'll multiply text box 1 by text box 2 after passing the values and text box 1 and text box 2 to integers, and show the results into a string. Then we'll clear out the values in the text boxes in the last 2 lines of code. This could easily be broken because if I entered any alphanumeric character, then this will cause problems. So when we're in debug mode of Visual C# 2005 Express Edition IDE, we'll get a message appear saying that a format exception was unhandled. But the end user will not see this message. We'll stop the application, find it on a hard drive, by navigating to our Visual Studio 2005 projects lesson 11, then to the bin directory, debug, then double click our lesson11.exe and wait and see. Then type A, then number 7, and we get an ugly .NET generated exception message. This wouldn't make any sense to the end user, and you don't want them to see this. So you might want to put a more friendly message box which says you're not using values that are acceptable to this application. Try using numeric values only, or something along those lines. So we'll quit this and rewrite our exception handling code around this and make it more user friendly. Now we can resolve this problem by something known as declarative exception handling by using the try-catch statement which we mentioned before. The try-catch statement defines a code block which is watching for exceptions as they happen. If they find an exception, then the code execution is diverted from the current line of code to a catch statement. It's possible to have more than one catch statement to catch more than one specific type of exception. You can also handle all the exceptions by catching the base system.exception class. So, in this example, we drag a second button, double click, then paste and code into my button 2 click event. This time we have the creation of our result integer on our first line. In the next line of code there is a try statement with an open and close curly brace. The 2 lines of code which was in the last example are between that code block where we're multiplying text box 1 by text box 2, grabbing the result in the next line of code and displaying it in a message box. So if we find a problem within the try block of code, then an exception will be thrown and now we can catch the exception. So I'm just catching a general exception, the base class. This will let me catch any exception that happens, so if there is a problem we can just display that in the message box. Lastly, the last 2 lines of code is where we clear out the text boxes. So we'll run the application once more. This time when I use an alphanumeric character, I get a friendlier message box saying there is a problem with your entry. Please make sure you use numerical values. So now the user knows they can't input alphanumeric characters. Now I can add another catch statement. As I mentioned before, you can add lots of catch statements so that you hone in on the problem which occurs within the try block of code. So catch, and we'll use the format exception and define a code block for that. So we'll copy this message box, which we used here, but now we'll change the general exception to remove some of the more specific text. We have no idea what the problem was, so we can type, we don't know what the problem was. Then we'll set a breakpoint here within our code, save it, then run our application. This time we'll type in A and 7 and click button 2. And I'm stepping through the code. I'll use my step into button. you'll see that it immediately jumps to the format exception catch block. That's where the error message is displayed, and that just tops over the next catch block, as we have found the most specific version of the exception rather than the most generic. So that brings up a best practice. I want to try the most specific exceptions first and the most general ones last. So here I'm catching format exception. Now if there were more expected problems with these lines of code, then I could add additional catch statements. I'm using the catch statement that catches the general exception for the most generic exceptions that may happen. So how to tell what exceptions can happen within your application? It depends on how well the testing is. When you're developing an application, you want to keep testing the application continuously. Think of ways to break the applications by maybe inputting too much or too little information in the text box, or none at all, by using alphanumeric characters or underscores or @ symbols, etc. So you have to think of creative ways of doing it. If you don't have a team of developers with you, you could maybe ask a friend, or to use your application for a while and see if they can break it. This is sometimes called beta testing your application. Giving it to a few people who would be happy to test out your application for a while before you give the application to everybody else that's interested in using it. So a lot of these kind of things will come out during that type of testing. This will give you the chance to recreate the problem whilst testing on your computer, and or find what the specific exception is and then catch that. You'd normally report the problem back to the user. However, there may be other creative ways to handle the problem. It could be that a file is missing that was expected to be in a particular location. So then you'd look at the parent directory or ask, is this a file you want to use? If the problem can't be solved without involving the user, then involve him once all the other avenues have been explored. So we can see how to use the try and catch statement. Now let's look at throwing exceptions from a custom class that you built. I've created a class called myClass, and in the definition of myClass I've added a single method that returns type double called myMethod that accepts the type double taxable amount. Then catch the value of the taxable amount. If the value is more than 100,000, then throw in a new instance of given out of range exception. The way I discovered this is through the IntelliSense and found that the exception already existed, so I basically knew that what I wanted to say within my exception. I could have chosen a number of different exceptions, but this was the better option. In the next example, I made sure the taxable amount is not less than 0. In that instance, I created generic exception, that's just the base class, exception ES, equals new exception, and I pass in a string, which is one of the overloaded constructors for the exception object. The string represents a message that the calling code can take a look at and then display the end user and log it in a log file. If both tests are successful, and the return statement at the bottom, then we can return the taxable amount times some tax rate, which in this case is 0.075. Now I've added a button 3 to my designer service of my form. Looking at the click event for button 3, I've created a variable called taxable amount. Then I'll retrieve the value of text box 1 and 2 by passing it into a double. I shall then create an instance of the myClass class which I made, then create a variable called result, where I'm going to retrieve the results of my method. Then there's my try statement, where I'm setting the result equal to myClass.myMethod, passing in taxable amount. Then I simply display the message box. The next two statements are where I'm actually catching the value from my class. If the user types in a value that exceeds the ranges that I've set in the myMethod, I can check for the I've been out of range exception, or in the second case, check for the general exception. In that instance, I'm not sure what message to display to the user, so I'll depend on the message property of the exception to do it. This isn't ideal, but it shows how to retrieve the message property from the exception object. So at the end of my catch statements, you'll see that I've added a new constructor to our try catch statement. That is a finally statement. A finally statement is used to execute regardless of whether the try statement is executed successfully or if it was interrupted and a catch statement was executed instead. The finally statement, regardless of the situation. So I'll set my instance of my class equal to null. This tells the garbage collector of the .NET framework that it should be taken out of the memory. I don't really need to do this, but it is something that's considered to be a best practice. And that is once you're done with your objects to set the reference equal to null. So we'll set a breakpoint in this first line of code on our button 3 click event and run our application. We'll then input some value like 25,000, then click button 3. Now we'll check the value of taxable amount. So it will return the value of the tax 1875 successfully in a message box. Then carry on running the application. Next we'll input value of -50, so click button 3, step through the code. This time it should pass the first test, however it won't pass the second test. So an exception object will be created. The message will be set in the constructor and then will be thrown to the code that called it, which is in our button 3 click event. We'll then show the message property of the exception object that was thrown back to our button 3 click event. In a message box, a taxable amount must be larger than 0. So to complete it, we'll do 110,000, click button 3, and now we will run this again. This time the first check to make sure the taxable amount is not greater than 100,000 will fire, and we'll throw a new argument out of range exception. This then displayed in the message box. We'll then execute that last line of code, my class equals no, and then end the execution. Now it's important to note that you shouldn't put the try-catch statement around every line of code that you write, because it will slow down your applications and you don't need to wrap every single line of code that you write in a try-catch statement. The only statements to wrap would be those who may have a tendency to blow up. For example, in this first line of code in the button 3 click event, I didn't include this in the try-catch statement, where the taxable amount equals double the pass textbox.1.text. It might be a good place to put a try-catch statement because I need to determine whether or not the value is alphanumeric versus numeric value that can be easily passed into a double. So here we are depending on the input from the end user. Now when we create new classes, we wouldn't need to wrap them in a try-catch statement because they wouldn't be easily broken within our application. When we're calling the myMethod method of the myClass and setting it in the taxable amount, we're aware that there's error checking which occurs there, so you would put a try-catch statement there, but it's not needed within the message box. That can usually be executed without any problems happening. So we need to be a little careful when choosing the lines of code that need to be wrapped within a try-catch statement. So if it's something that we can handle ourselves, we don't need to wrap a try-catch run. But if we're relying on an external resource or the method of some class that we don't control, that we don't know how it works, that we may not want to wrap that within a try-catch statement. When writing your code, be aware of what the line of code is doing and how it could be broken. If you believe it can't be broken, and when doing a calculation you've already checked the values before you perform the calculation, then you wouldn't need to wrap it in the try-catch statement. But if there's a tendency to break when you work with files or user input, then it's a good idea to wrap it in a try-catch statement. So we've discussed ways of making your application more stable and less easily broken by introducing the concept of the try-catch statement. This is a form of declarative exception handling, We discussed exception object and how it's the base class for all of the specialized exception classes that are used within the .NET framework. We can also create our own exceptions, and whenever we're creating our own classes, we can use this to throw exceptions back to the calling code of our methods within our objects. We also looked at the ugly messages your end users will see when you don't try to handle the exceptions within an application. So that's it for today, and until the next lesson, I'll see you and take care.